the U.S. Navy has just revealed a powerful new weapon that could reshape modern warfare. It's not a missile or bomb, but something far more advanced, a high-powered laser capable of destroying targets almost instantly. This breakthrough could shift the balance of power on the battlefield. But what does it mean for global security? And how are other countries responding? Let's dive into the details of the Navy's most powerful weapon yet. Since the 1960s, nations have been developing laser weapons, and for good reason. Lasers have major advantages over traditional weapons. They travel at the speed of light, leaving no time for enemy response. This is especially valuable in aerial combat. Lasers have no recoil, don't require ammunition, and are only limited by the energy supply. Imagine a focused beam that can slice through targets instantly. That's what the U.S. has achieved with its latest laser system. Before this latest system, the U.S. had already deployed several combat lasers. One example is the Boeing YAL-1, mounted on a modified Boeing 747. It was designed to intercept and destroy missiles, including nuclear ones. The YAL-1 marked a major leap in laser technology and helped lay the foundation for the Sky Dominator NAD program, which aims to build next-generation laser-equipped fighter jets. The YAL-1 used a precise laser beam to destroy targets mid-flight, preventing them from reaching their destination. With a range of hundreds of miles, it eliminated threats without the need for traditional ammunition, cutting defense costs and changing global missile strategies. But that was only the beginning. These systems are capable of taking out aerial threats and even disabling nuclear facilities from a distance. In McKinney, Texas, the first laser weapon system for the U.S. military was built in just 9 months at a specialized facility. Mobile laser systems like the M-SHORAD have since followed. Mounted on the Stryker A-1 8x8 armored vehicle, M-SHORAD features a 50-kilowatt laser designed to destroy artillery shells mid-air. It dramatically improves battlefield defense during heavy artillery attacks. With advanced radar and targeting systems, it can accurately lock onto and neutralize missiles, aircraft, and incoming fire. Smaller laser weapons are also in development. One version, mounted on a pickup truck, uses a 10-kilowatt laser to shoot down drones while staying mobile and hidden, perfect for frontline protection and rapid response defense. At sea, laser weapons are just as critical. Lockheed Martin's Helios system, now installed on the USS Preble, is among the most advanced. It can shoot down hypersonic missiles and attack drones within seconds, something traditional systems can't match. Experts say Helios can destroy a Mach 5 missile within 1 to 2 seconds of detection. A key advantage of ship-mounted lasers is that they don't rely on ammunition, which is vital for long missions or operations far from supply lines. Of course, developing systems like Helios hasn't been cheap. Research and testing costs have run into the hundreds of millions. Lockheed Martin estimates that even mid-range laser systems can cost between $100 million and $500 million. With a 60-kilowatt output, Helios is best suited for smaller threats like drones and sensors, but it highlights the growing role of lasers in naval defense. A major milestone came when the USS Portland was fitted with the 150-kilowatt laser, enabling it to target cruise missiles and fighter jets. Lockheed Martin went further, developing the IFPCL, a 300-kilowatt system that combines multiple laser beams into one stronger beam. This system handles complex threats, operates in bad weather, and can destroy fast-moving targets in seconds. Its strength lies in detecting and neutralizing threats in real time, protecting personnel and equipment with speed and precision. The most groundbreaking development yet is the ultra-short pulse laser, USPL system. With a staggering 1,000 megawatt output, it's thousands of times stronger than current systems. Unlike traditional lasers that melt targets, the USPL destroys multiple threats in a fraction of a second, regardless of speed. With pulse durations in the picosecond range, it can instantly disable a missile or aircraft by damaging critical components before they can react. This is crucial for defending against hypersonic missiles and UAVs. Modern USPL systems cost between $50 million and $100 million, depending on their configuration. While expensive upfront, they don't need ammunition and have low operational costs, relying only on electrical power. This makes them more efficient and sustainable over time compared to traditional systems. The US, China, and Russia are all investing heavily in USBL technology, driven by the growing threat from drones and ballistic missiles. USBLs can destroy targets hundreds of miles away and are largely unaffected by weather conditions like fog or smoke. With this level of power, laser weapons are set to play a central role in the future of warfare. Lasers are powered by energy, but delivering that energy is far from simple. At first glance, it might seem easy. Just power up a machine and fire. In reality, it requires advanced energy storage and delivery systems, especially since traditional power sources aren't always reliable in combat zones. Nuclear power was once seen as a viable option, but reactors are bulky and too risky on the battlefield. Scientists are now exploring quark fusion, a groundbreaking alternative that generates 8 times more energy than conventional nuclear fusion, without triggering dangerous chain reactions. This makes it not only safer, but also far more efficient for powering high-energy laser weapons. With nearly limitless energy, quark fusion could allow lasers to strike targets hundreds of miles away. No ammunition needed. A laser powered this way could take down a hypersonic missile in just 1 to 2 seconds, much faster than existing systems. While hypersonic missiles can travel at Mach 6 or more, a quark fusion laser could track and neutralize them almost instantly. But despite the promise, quark fusion remains a developing field. Early research could cost billions, though long-term operation would be far cheaper than traditional systems. Even as laser weapons advance, several challenges remain. One issue is detectability. Every military device emits a unique electromagnetic signature, and high-powered lasers are no exception. These signals may be invisible to the eye, but modern radar systems can pick them up and identify the source. For example, ultra-short pulse lasers produce distinct signatures that make them easier to detect, reducing the element of surprise during combat. Research by the U.S. Air Force has shown that these signals can be detected from several hundred meters to a few miles away. Once a laser is activated, enemy forces can quickly trace its origin. Advanced systems like the U.S. Army's AE/MPQ-53 radar are particularly effective at pinpointing these emissions, increasing the likelihood of a counterattack. Another limitation is that lasers require a clear line of sight. Unlike missiles or artillery that can arc over obstacles, lasers must see the target. If a threat is hidden behind terrain or buildings, it's unreachable. This constraint puts lasers at a disadvantage compared to traditional weapons. To overcome this, developers are working on combining lasers with autonomous systems that improve reaction time and targeting accuracy. These innovations could reduce the need for human input and reshape modern defense strategies, but much more work is needed before full deployment. While U.S. laser weapons draw most of the spotlight, an important development is the collaboration between the U.S. and Israel. Their joint efforts began in 1996 with the tactical high-energy laser THEL, designed to use chemical lasers to intercept threats. It showed early success, but was ultimately canceled in 2005 due to cost and size issues, after surpassing $300 million in expenses. In 2007, Israel revived the concept with the Sky Guard project, aimed at countering Qassam rockets. That program evolved into what is now Iron Beam, developed by Rafael Advanced Defense Systems, with help from Lockheed Martin for U.S. applications. Iron Beam uses solid-state lasers to intercept short-range threats like rockets, mortars, and drones. It focuses intense energy on targets, destroying them in mid-air. Also known as Magen or Light Shield, Iron Beam is a key part of Israel's air defense. It can operate alone or in coordination with radar and surveillance systems. The concept was first presented at the 2014 Singapore Air Show, and by 2017, a working demonstrator was operational. Originally mobile, the system was later adapted to a fixed setup due to power and weight limitations. By 2023, Iron Beam was capable of delivering 100 kilowatts of energy, focused to the size of a coin at a distance of 10 kilometers. This was demonstrated in successful 2022 tests at White Sands Missile Range, where the system destroyed drones, mortars, rockets, and anti-tank missiles. Encouraged by these results, Israel aimed to accelerate deployment to complement the Iron Dome. Still, challenges delayed full deployment. By late 2022, Rafael projected a 2 to 3 year timeline to readiness. In May 2023, a naval version of Iron Beam was introduced, designed to defend ships against drone swarms and anti-ship missiles, emitting 100 kilowatts over several kilometers. This version shares the same size as the land-based system and can be mounted on ships or deployed in modular containers. The first installation is expected on Israel's Reshape-class corvettes within a few years. By October 2023, plans were announced to deploy Iron Beam along Israel's southern border with Gaza.